Good morning. Myself Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligudem. Today I am going to deliver my second lecture on Chemistry of Materials belonging to the course Engineering Chemistry. So in my first lecture, I had discussed about the introduction to nanomaterials. So in introduction, I have discussed what is meant by a nanomaterial, classification of nanomaterials, coming to classification, we have classified the nanomaterials as zero-dimensional materials, one-dimensional nanomaterials, two-dimensional nanomaterials, and three-dimensional nanomaterials. After that, we have discussed the various properties of nanomaterials. The properties that were discussed were physical properties, chemical properties, magnetic properties, electrical properties, and mechanical properties were discussed. And next we have discussed about the approaches of nanomaterials. So what are the approaches to nanomaterials means? Top-down approach, here approach means approach to the synthesis of nanomaterials, and bottom-up approach. Top-down approach means here we will be starting with the materials which have bulk size, and that bulk material will be made into nanomaterial. Here, the bulk material can be transformed into nanomaterial either by cutting or by grinding or by etching. And coming to the bottom-up approach. In bottom-up approach method, we will start with the substances or materials which have size less than nanomaterials. That means here we may start with atoms or molecules, and these will be transformed into nanomaterials. How means? By placing atom by atom, molecule by molecule, or cluster by cluster. So these are the two approaches we will be following for synthesizing the nanomaterials. Now coming to the synthesis of nanomaterials. So in the earlier class we have discussed about sol-gel method. The sol-gel method of preparing nanomaterials will come under bottom-up approach method. Here we will be preparing a sol, and this sol will be formed into gel. After that it will be dried, and after that we will be transforming into nanomaterial. So coming to this method, mainly used to prepare metal oxide nanoparticles. So in this method, the precursors means starting materials. The precursors are metal chlorides or metal alkoxides. So these will be undergoing hydrolysis and polycondensation reactions. So how this hydrolysis and polycondensation reactions takes place means, so in this method, first one is the formation of salt. So here, metal alkoxides will undergo hydrolysis. Metal alkoxides means MOR. These will undergo hydrolysis. Next one is gel formation. Here it undergoes condensation followed by polycondensation reactions. So here, during water condensation, water will be formed. And during alcohol condensation, alcohol will be formed. So these metal oxo compounds will undergo condensation reactions and forms the gel. So after gel formation, next one is drying process. So in drying process, removal of pore liquid takes place. That means the liquid which is existing in the pores will be removed. Here, under hypothermal conditions, here what happens means aerogels will be formed, and under ambient conditions, xerogels will be formed. So aerogels and xerogels will be formed. So here how the xerogels will be formed means the pores will shrink. And the next one is calcination. Calcination means the process of heating a material to high temperature but below its melting point. That means here thermal decomposition of the material takes place. So here the xerogel, it will be heated to 800 degrees centigrade. then what happens means the pores in the material will shrink, as well as the organic material, whatever is there, it will be evaporated. Next one is heating process. This heating process is done to give a desired shape to the material. That means the material can be transformed into fiber or as wire or as powder. So these will be simultaneously transformed into ceramic material, subsequently transformed into ceramic material. After that, we have discussed about the advantages of this sol-gel method. So what are the main advantages of this method means? The sol-gel method is cheap and when carried at low temperature, and metal oxides can be prepared, very thin metal oxides can be prepared, and we can prepare nanomaterials like fibers, wires or powder, and this is the best alternate method for the synthesis of glass. And this method has some limitations. What are that limitations means? Bonding is very weak, low wear resistance, substrate dependency are some of the limitations of this sol-gel method. So now coming to our second lecture. So second lecture is on chemical reduction method, CIM and TEM. Madam, I want to take pen. Last one, each I have to. So this chemical reduction method will come under bottom-up approach method. Earlier sol-gel method also comes under bottom-up approach method, but sol-gel method is used for the preparation of metal oxide nanoparticles, and this chemical reduction method is used for the preparation of silver nanoparticles, gold nanoparticles or platinum nanoparticles. I will explain this method by taking the example of preparation of silver nanoparticles. Here we will be taking silver nitrate of concentration 1 to 6 ppm. This will act as metal precursor and to this we will be adding sodium dodecyl sulfate Here we will be taking 8% weight by weight sodium dodecyl sulfate. This acts as metal stabilizing agent. And these two will be treated with reducing agents. The reducing agents used are hydrogen hydrate, concentration 2 to 12 ppm, and citrate solution of 1 ppm. So after adding all these, initially the solution will be colorless, but after some time what happens means pale yellow or pale pink color appears. The formation of this color indicates the formation of silver nanoparticles. So next what we have to do means removal of excess of silver ions. How we can remove means by washing this one with deionized water under a stream of nitrogen for 3 times. As a result, what happens means excess of silver ions will be removed. Next, pure silver ions. Purification. Purification can be done through centrifugation. Next, drying process. Here, the nanomaterial can be dried through freeze drying. You will be getting dried powder or dry powder of silver nanoparticles. And these can be characterized by using UV and X-ray crystallography studies. So these are the 2 preparation methods for nanomaterials using bottom-up approach. Next topic is electron microscopy. Electron microscopy means it involves the study of different specimens using electron microscope. Electron microscopes are scientific instruments that use beam of energetic electrons to examine objects on a fine scale. Using electron microscope, one can see the things that could not be able to see with our naked eye, and it requires greater magnification than current optical microscopes. So coming to the types of the electron microscopes, there are 2 types of electron microscopes, SIM and TEM. SIM means scanning electron microscope. TEM means transmission electron microscopy. Here, in scanning electron microscopy, here images will be formed from electrons that bounce off the surface of specimen. And in TEM, transmission electron microscopy. Here, images are formed from electrons that transmit through the specimen. Specimen means nothing but the object whose image is to be taken. So now coming to the scanning electron microscopy. Basic principle is that a beam of electrons is generated by a suitable source like tungsten filament or electron gun. High voltage is used to accelerate the electron beam, and thin beam of electrons is produced by passing through a system of apertures and electromagnetic lenses. Surface of the specimen is then scanned by the beam. Electrons emitted from the surface are collected by a suitably positioned detector. So now coming to the instrumentation. Electron gun. So there are two types of electron guns. Thermionic guns field emission guns. In thermionic guns, tungsten will be used, which has high melting point. Field emission guns means they will produce high electric field so that it will be able to pull the electrons from the specimen they are associated. So here in field emission guns, what they will be doing is they will be producing strong electric field and they will fire a beam of electrons onto the specimen. But these electrons which are fired from the electron gun will not accurately go to the specimen. For that, what we'll be doing means so for producing the electric field, anode and cathode will be used. So next one is condenser lens. So here the electrons which are fired from the electron gun will not reach exactly to the specimen. That means they will not go exactly to the position where they have to go. So for that, what we'll be doing means we'll be using the condenser lens. So these condenser lens are not made of glass. They are usually made of magnets. Why means if they are made with magnets, they can change the path of the electrons coming from the electron gun. And these are responsible for producing clear image of the specimen. Clear or detailed image. Next, this one is called scanning coil. The scanning coil will be moving in and out so that different sized holes will come into the position of the electron beam. So next one is the sample chamber. So this is called the sample chamber. Sample chamber means this is the chamber where the specimen under examination will be placed. This sample chamber must be steady and it must be insulated from vibration. Next is secondary electrons. Secondary electrons means these are the electrons which are produced by the collision between the incoming electrons and the loosely bonded outer electrons of this specimen. And these secondary electrons are responsible for producing the image. That means these secondary electrons are responsible for topography of the specimen. That means surface image will be given from these secondary electrons. These secondary electrons will have low energy of 10 to 50 electron volts. Next, these are the backscattered electrons. Backscattered electrons means if the scattering angle is greater than 180 degrees, then the electrons will escape from the specimen. That electrons are called as backscattered electrons. These backscattered electrons will have high energy. And these backscattered electrons are few in number when compared to the secondary electrons. So this is how we will be recording the image using scanning electron microscopy. Here, the detectors will be detecting the secondary electrons and backscattered electrons. For detecting the secondary electrons, the detector that is used is Eberhard, Thornley, detectors. This detector will detect the secondary electrons, and this backscattered electrons will be detected by solid state detectors. So this is the SEM image that is obtained from blood, and this is the SEM image of titanium oxide nanoparticles coated with carbon. So I told you this requires high magnification and the energy for secondary electrons is less, and this is the image that is obtained. Now the second one. Second method is transmission electron microscopy. So transmission electron microscopy means, already I told you, this will produce the images by using the electrons that are transmitted through the specimen. So coming to the instrumentation like SEM, this will also have electron gun which is placed at the top of the transmission electron microscope, and next condenser lens, after that specimen. So here specimen will be placed here, but in the case of SEM, specimen will be placed at the bottom of the scanning electron microscope in a sample chamber, and here it will be having objective aperture lens. This lens is usually made up of metal rod, and this will hold the specimen. And next, these are the intermediate lenses, and this objective aperture will be moving in and out so that different sized holes will come under the path of the electron beam. And this is the fluorescent screen. So this will gives you the image of the object, detailed image of the object. So this is the TEM image of titanium nanoparticles in sunscreen applications. So this is the software that has been used for taking this image, and this is the size of the particle, and here the energy used is 80 kilovolts. So now we will discuss how the SEM and TEM differences. Coming to SEM, SEM is based on scattering electron capture, and TEM is based on electron transmission technique. And this is used to study sample surface and its morphology, used to study detailed internal composition. Sample size is thick here and the sample size is thin. See here once. See, very thin sample size we are taking. Low resolution, high resolution. Large amount of and multi-phase analysis of sample is possible in SEM, and in TEM, small amount of sample can be analyzed. Images will be appeared on monitor or on picture tube. Here images will be shown on fluorescent screen. See, image will be shown on this fluorescent screen. In SEM, three-dimensional structure can be observed, and in TEM, two-dimensional structure can be observed. And SEM is used for surfaces, powders, polished and etched microstructures. And TEM is used for imaging dislocations, tiny precipitates, grain boundaries and defects in solids. Now coming to the applications of SEM. SEM finds applications in research, industries, and commercial sector. So what are the major applications of SEM means? SEM is used in material science, biological science, forensic inspections, microchip assembly, soil and rock sampling, semiconductor, etc. Next, upcoming to the applications of TEM. TEM finds applications in virology. That means it's a branch of microbiology which is used to study the viral diseases. Used in material science, cancer research, as well as in pollution, nanotechnology, etc. It is also used in paleontology. Paleontology means study of the forms of life in prehistoric age. And in palynology. Palynology means study of particulate organic matter in various matrices. That means in air or in crime scenes, etc. So these are the major applications of SEM and TEM. Thank you.